Hello, welcome again to RP-0 America. So this is our probe that we threw towards Mercury, and it is approaching Mercury. So there is the super bright sun, which I believe scatter makes much larger and brighter, which is awesome. As you get closer, I pointed my solar panels a bit closer to direct. I'll need to check this this is a good opportunity to double check that the energy flow, the output of solar panels, is increasing when you're closer, when your orbit is closer to the sun. So right now we're at 118 watts at about 90% exposure. Here, let's see, can I tip? Weird little wiggly wobble. They're at the ends of those sticks. Here, let's get a little closer to direct on. Yeah, close enough. So yeah, we're getting about 125 watts at 95% value. So there's the bright sun. Now can you see Mercury? So right over here you can see just a little bit of the edge of Mercury. So let's take a look. We are 30 minutes until we enter the sphere of influence of Mercury, and we are also just over 2 hours away from closest approach to Mercury, and then just under 4 hours from now we will be out of the sphere of influence of Mercury. And you know, if you've played with stock or other planets and moons as well, you might think, okay, well, that's a really short time to be in the sphere of influence. Perhaps Mercury is light. No, Mercury is not a particularly light planet. It is because we are just moving so fast compared to Mercury. I believe this encounter is so darn short. And I've been kind of driving that home by mentioning it in every video, but I just want to continue driving that home, that, let's see, that, well, it's going to be a very short encounter period with Mercury. Alright, so let's focus, view, and zoom in. Alright, so I just wanted to make sure that our encounter is going to be on the sunlit side of Mercury. And I'm going to do, you know, a fairly close skim so we get a decent view of this little strip of Mercury. And this is just a good, you know, this is just a useful test mission. I'm not, if you look at like the first missions that went to, I think it was Mariner 10, I mentioned it in a previous video. It did a flyby of Mercury. It was able to scan and get like a quick bit of pictures as it flew by a certain arc of Mercury, and that's the kind of thing we would probably get from this if we had like ScanSat tools on board. Oops, sorry, I bumped the camera there, or my my microphone, which is a webcam. Alright, so I'm just going to warp towards that encounter. And we should see a kind of a blip of all our values. You know, this orbital velocity. This is we are moving with 51. Actually, that's an interesting comparison. So we're moving about 51 kilometers per second in relation to the sun. And if we look at Mercury, let's switch back views. Where is Mercury itself? There's Mercury itself. So it's moving at 40 kilometers per second. So that difference is going to be, you know, that's the same reference frame. So that difference between those is going to be our relative velocity, the speed we're going to be passing by Mercury, plus we're also going to accelerate a bit towards Mercury because it has a gravity well, because it is a large extended body with substantial mass. So we're going to see those things change as we there we go. I think it's slowing down before we move into the sphere of influence of Mercury. Fair enough. Close, delete on close. Yes, it no longer needs to alert me that we are going to be entering the sphere of influence of Mercury. Okay, and one other thing, I don't want to miss this flyby. Well, actually, here, yeah, see, even just clicking that, I can't, I don't know, these lines, these paths just have a proclivity, a desire to give me the option the next cycle around, which confuses me because I don't think there is a next cycle around. I wonder if maybe something is messing with that, some mod or something. Anyway, I'm going to use Kerbal Alarm Clock so that I make sure I don't fly past that. Oh, here you can see. So I've built, so in my previous video I did a basic demonstration of Hydrolox technology, so I need to improve the reliability of those engines. And so I built an Atlas Centaur test vehicle, which I called dummy because it has no real payload, because I don't know, I like to follow history. You know, the first 3 or 4 Atlas Centaur test vehicles just failed brutally badly, and you know, I expect that could potentially happen one of my kind of dry run tests of the craft failed, just one of the engines lost thrust. And, you know, so I expect to not have good luck with the first run or two of that. And I prefer to do a flight because then I can talk about the vehicle and various things rather than just using the test flight R&D system, even though I really should use the R&D system because it needs a little bit of attention to give us good estimations of what the R&D should cost for various things. Okay, so just transmitting the data as we had just entered the sphere of influence of Mercury. Okay, I'll just let those go by since I'm not going to have any trouble with running out of battery power. Okay, so we are an hour. Oh, there we go. Now we're in the sphere of influence, so I could set up a maneuver. So I'll warp a little closer. So you can see Mercury, it might get larger during this period. We are moving towards it very fast. Every second we're getting 20 kilometers closer to Mercury. Oh, that sun is very bright. Actually, can I just, sure, I'll try that. Just pop the craft over the sun so we can watch Mercury approaching there. Okay, so let's add an alarm for not sphere of influence change, ascending, descending, closest, not target, well, let's go with this. Closest when we're at periapsis, closest, and that, just confirming those numbers, that makes sense. Good, so it's going to slow us down before we actually approach the body. So I'm just going to watch it out of the corner of my eye here as we approach, so it's going to get bigger and bigger. So we're approaching kind of from the dark side, and we're going to swing by the bright side. There we go. So we're getting closer. I'll kind of focus my camera on Mercury now. And let's see, how is that? So just the craft is being artificially lit by ambient light adjust, as I normally do. And I don't know, I'm going to set it, oh, we got some more science because we're much closer to Mercury and possibly over another biome. Alright, and actually let us do a quick peek at the biomes of Mercury. There we go. So I don't know what they're all called, but that's what they look like. The various biomes of Mercury. There are a lot of them. A couple that look like they're polar. Actually red, that's not just polar. Yeah, quite a vibrant biome map of Mercury. Absolutely. Oh, some more science to capture, so let me just hide that again. Capture more science. Oh, no. Just capture the science. Just the science, ma'am. Okay. So we're getting closer and closer. So how far are we away? We're a minute from closest approach, and we're already we're at around 1,000 kilometers away. And we are accelerating. We were already moving very, very fast, but we have no chance with this craft of getting into orbit of Mercury. You have to either use an insane vehicle with like an insane amount of delta V to get into orbit of Mercury, or you need to be NASA level clever, which some KSP players are and I am not, where you can do multiple assists from other planets, including Earth. It's weird. You can do a path such that you swing by Earth in a way that it slows you, you lose velocity, and make it easier to get a capture around Mercury. Alright, so we are approaching, what does it say? I guess we've got time to Apo, but we don't have a listing of time to periapsis. I wonder if we'll get close enough, if we're going to be close enough to have it switch. So right now it's kind of showing us what Mercury looks like. Yeah, you can delete that. What Mercury looks like from space, so the scaled space rendering of it. And soon we will be seeing potentially the PQS, so the way it renders the ground when you're close enough to it to land, just like the way the land of the moon looks like when you land, or the area around your launch pad on Earth looks like before you land. Because right now it's kind of blowing up these pictures as you would view them from orbit, and then it makes that transition. There we go. So you can see it's making that transition. It's rendering the things. So those the craters and such we were seeing from the other view aren't quite as stark. Like one thing I've noted is that the moon, you really see that connection between the rendering mode of one and the rendering mode of the other, as they really pop out. from the ground. But I mean, we're moving insanely fast. Really, the scale of things is exaggerated and crazy because we're moving so fast. So, but I'll have to let Kill Ashley or other people who know how to manipulate planets take a look and see how this compares to what they'd expect it to look like from how it's rendering it in the PQS there. So we got to closest approach over some biome and gathered a whole ton of science. And let's get some more. Mercury Planatia, okay. Let's gather and transmit a ton of science. And now we're moving away from Mercury. So at closest approach, we were moving roughly 20 kilometers per second with respect to the ground, which is amazing. That is an amazing speed. And there we go. So it is switching to the other rendering mode. So if we had been able to, and this craft is just tiny enough to say, yay, we did it, and we got some science from being near Mercury, but not good enough technology to send scan sats or something. So we'll have to send, later on, a heavier craft to Mercury with some ScanSat hardware to snap some better better pictures and take some better data. So is that a pole? Usually when like a bunch of lines and stuff are coming together, it's the pole of a planet. No, that's just like a really weird impact point. Interesting. Very interesting. So that's a real feature, not just the fact that this is effectively a skin that's being stretched over a ball. So that's neat. Mercury is a very odd-looking body. It's very, very iron-rich. If we were able to extract some of the materials there, who knows? It's also really close to the sun, so it gets impacted really harshly by the sunlight and the solar wind. I don't recall offhand if it has its own magnetic field or not, but it is a brutal planet that we have now visited. And we've captured what appears to be as much science as we're going to get. And now this craft is going to swing out. So Mercury is moving much slower in relation to the sun than we were. So we're going to swing past and overtake it in our path around the sun. So that means the sun is that way, yep. So we're basically passing it in the fast lane. And it probably diverted our path a little bit. It's just going to be a little bit of time till we're back out in interplanetary space. And I selected the Earth for targeting. So this will be showing, so we swung past Mercury. Actually, we're still on the way in. We haven't quite got as close to the sun as we will. In 9 days, we will be within 63 million kilometers. I think that's right, just under 63 million kilometers distance of the sun. And so we will be out over at this point. And where is the Earth now? So the Earth is here, and it will have moved here by the time that we are out moving past Venus and moving out towards the Earth. So in theory, if we were very careful and took the right measurements, you could send a probe where it did a flyby of Mercury or Venus or Mars, just kind of setting the arc for things I will hope to do in the future, do a flyby of another planet, and then catch Earth in the same in another position. So with Mercury, you'd probably have to do a resonance of some kind, as in, so rather than say, imagine it was exactly 365 days of the orbit of the Earth. So you'd want to set up your orbit so that it was a whole precise fraction of that. So say we would arc out by Earth, and then we'd do a couple flybys of Mercury or near Mercury's orbit, and then so the Earth would be back around some position, say where we had originally taken off from it in its path, and then we would do a close approach flyby. And that's an accomplishment I've never made in real solar system, flying by another planet and returning. Bevo has done it, and congratulations to him. And I still need to figure out the tools for how to do that. But ultimately, that's something I'm definitely interested in, because rather than say having to slow down into the orbit of Venus or Mars, and then accelerate out of the orbit of Venus or Mars back to Earth, if you plan a clever and careful flyby of a planet, then for a not very much delta V, you can visit that planet with a human crew and return them to Earth, which is great because ultimately sending a probe like this is 200 kilograms. It doesn't need water. It doesn't need food or entertainment, right? So sending a craft with people to do a flyby of another planet is extremely heavy, and so the heavier your payload is, the more fuel you'll need to do all the things you want to do in that mission. And so, oh, there's a weird blip. It went dark while we were, I assume that was us switching spheres of influence. So now we're out in orbit of the sun, accelerating towards our closest point of solar approach. But I think we've got all the science we can from that mission. So that was a great success of our Mercury flyby. The sun is oh so very bright this far down and close to the sun. But yeah, thanks for watching this episode of RP-0 America. Next time I will actually do our first practical launch of the Atlas Centaur vehicle. Just brighten this guy up again. The Atlas Centaur vehicle, so we'll do the first actual test of our Hydrolox second stage engines. Thanks for watching. Goodbye.